Earth, a 4.5 billion-year-old planet, still evolving. As continents shift and clash, volcanoes erupt, and glaciers grow and recede, the Earth's crust is carved in numerous and fascinating ways, leaving a trail of geological mysteries behind. In this episode, the Mariana Trench, the deepest point on Earth, is explored. Its sheer walls cut 7 miles into the Pacific Ocean. The mystery of what created this deep, dark chasm takes science detectives on some of the most dangerous dives ever attempted. Deep into the abyss. Scouring the ocean floor, scientists uncover a strange undersea world of fiery mountains, bizarre mud volcanoes, and the largest geological structure on Earth. Discoveries from this unique underwater world will revolutionize our understanding of the powerful forces that shape not just the trench, but the Earth itself. Hidden deep beneath the waves of the Western Pacific lies the Mariana Trench, the deepest point of all the oceans. The first step on the journey of what created this mysterious scar in the Earth's crust and how it continues to mold the planet takes us back to 1872, when a British research vessel, HMS Challenger, set out on the first ever mission to map the ocean floor.
Throughout most of recorded history, men had just assumed that beyond a certain level the sea was pretty flat, pretty dead, fairly lifeless. They weren't expecting to find anything very interesting.
For 4 years, the Challenger crisscrossed the oceans, covering 70,000 miles, a third of the distance to the moon. The crew plumbed the depths every 140 miles, using a total of 249 miles of rope and hundreds of pounds of lead weight. It was tedious, backbreaking work, but at the time it was the only way to measure the depth of the ocean floor. When they got to the Western Pacific, 200 miles off the island of Guam, the crew routinely lowered the rope for a measurement. But the weight kept on dropping and dropping.
It's a big surprise. Nobody thought the ocean was this deep. So all of a sudden we've got scientists saying, why is that?
Eventually, the weight struck the bottom at 4,475 fathoms, nearly 5 miles beneath the ocean's surface.
The scientists will be going, wow, we've found something, and what does it mean? Is it a little hole? Is it a big hole? What kind of feature is it down there? There's a whole lot of questions you get when you find this one spectacular reading.
The Challenger expedition marked the birth of modern oceanography and provided the first crude map of the ocean floor. It showed how the ocean floor gently slopes away from the land and then plummets thousands of feet into vast flat plains. But the Western Pacific is different. It drops off again into the 5-mile deep hole, a hole that blew right out of the water the long-held belief that the sea floor was flat and featureless. And it spawned a mystery, because nobody could understand how this strange underwater feature came about. It would be 75 years before any answers emerged. It took a revolutionary new technology, sonar, to push the investigation forward to the next crucial stage. Sonar was first developed in the early 1900s and then perfected during the 1940s to detect submarines lurking in the deep. The system works by pumping sound waves through the water. The waves bounce off solid objects and are reflected back to a detector. By measuring the time it takes for the sound waves to bounce back, scientists realized they could build a remarkably accurate picture of the world beneath the waves.
The world's major navies spend a lot of time and effort developing submarine hunting technology. Then the hydrographers discover that you can use this to chart the bottom of the sea. And it's an awful lot cheaper and easier than using large numbers of sailors pulling on ropes.
In 1951, a British Navy research ship returned to the deep hole found by the Challenger expedition. But this time, they were armed with sophisticated new sonar equipment. And the results were amazing. Detailed sonar maps revealed that the deep hole in the Pacific Ocean floor isn't a hole at all, but part of a massive trench, 30 times deeper than the Empire State Building is high. It runs twice the length of California, 1,500 miles from the southeast of Guam to the northwest of the Mariana Islands.
People were probably astounded by what they were seeing because clearly the ocean floor had enormous changes in relief, was very mountainous in some places, had great deeps in other places. To a geologist, this would be extremely exciting.
Even within the trench itself, there are remarkable variations. At its southern end lies the greatest surprise of all. The seafloor drops down another 2 miles to its lowest point, a staggering 7 miles beneath the waves. Scientists had discovered the deepest part of the oceans. Even today, it is the lowest known point on the planet. They named this part of the trench the Challenger Deep, in honor of the ship that discovered it.
To get a sense of just how deep trenches are, if we take the height of Mount Everest, we would still have about a mile of water above us before we get to the ocean's surface.
But how the Marianas Trench was formed remained a mystery. Investigators decided the best way to find the answer was to dive to the bottom of the trench, to see for themselves the lowest point on the planet, the Challenger Deep. But they faced a major problem. At the bottom of the trench, they would have to contend with pressure 1,000 times stronger than at the surface. That's the equivalent of being squeezed on all sides by the weight of 50 jumbo jets. To demonstrate the effects of such pressure, scientists use a dummy head.
Today what we're going to do is actually put one of these styrofoam wig heads in the pressure chamber and expose it to the pressure we would see in the Marianas Trench. That's about 16,000 psi.
A human skull would be crushed to a pulp, but the rubbery head will only have all the air squeezed out.
Wow, that's smaller. And here's what the original size was, just for comparison. Quite dramatic. Pretty stark difference between something that hasn't been 7 miles deep in the ocean and something that has. Glad I'm not going there. At the Mariana Trench, human life is impossible. We're not equipped to resist those kinds of pressures. And so it's necessary to protect humans from that type of an environment.
The challenge to engineers was how to accomplish this. In 1953, Swiss scientist Auguste Piccard designed the Trieste, a pioneering vehicle that could withstand the crushing pressures. The submersible was dominated by a 50-foot-long hull, filled with light aviation gasoline and lead weights to control buoyancy. Slung underneath it was a tiny 6-foot spherical cabin with 5-inch thick steel walls. Finally, after 7 years of modifications and manned test dives no deeper than 3.5 miles, the Trieste was ready to attempt the 7 miles to the bottom of the trench. The commander of this perilous undertaking was U.S. Navy Lieutenant and deep-sea explorer Don Walsh.
I know the astronauts that go through this all the time. Why do you have to be there? Why can't we just put up a robot to do things? You've got to be there because that's what we do.
Only a few officers and scientists knew about the risky mission, which was launched in January 1960 from the western Pacific island of Guam.
Guam, in those days, was kind of a backwater. It was just right for us because we were trying to do this project sort of out of sight because we weren't too sure it was going to work. The Navy just didn't want to be embarrassed by a failed science spectacular.
Accompanying Walsh was the son of the Trieste designer, engineer and oceanographer Jacques Piccard. The two men would spend the next 9 hours squeezed inside the cramped sphere.
And we had 20 cubic feet of space inside. That's about the same as a household refrigerator. And the temperature was almost that cold inside. It was a drama.
The story of how the Marianas Trench came to be is beginning to take shape. In 1874, British surveyors were the first to discover a 5-mile deep hole in the ocean. 75 years later, sonar mapping revealed the hole to be a vast 1,500-mile-long trench, with the deepest part 7 miles beneath the surface waves of the Pacific. To gather further evidence, 2 courageous men were about to undertake the most dangerous dive in history. They would venture into the abyss and go to the bottom of the Marianas Trench. The Marianas Trench is one of the most remote, inhospitable places on Earth. In January 1960, 2 deep-sea explorers, Don Walsh and Jacques Piccard, plunged into its depths on board the submersible, the Trieste. At a speed of just 3 miles per hour, they began their slow descent into the twilight zone. By 3,000 feet, the darkness was total. The only illumination was from the Trieste's powerful lights.
The depths we were operating at, it was always black. The only thing that lit up the abyss was the bioluminescence from animals and plankton. Like fireflies, they carry their own light sources with them.
Encased in their 5-inch thick steel sphere, Walsh and Piccard quickly passed their test dive record of 18,000 feet. Everything appeared to be going to plan. At the rear of the cabin, the crew were protected by a double layer of glass. But 2 hours into the dive, the outer pane cracked.
We had a great big bang. We didn't know what it was. We were about 20,000 feet. And we looked around and checked everything.
Every square inch of their tiny life-supporting capsule was fighting back 8 tons of pressure. With the outer pane broken, the only thing between the men and instant death was a single pane of glass.
If the inner window had cracked, we would have been instantly dead, maybe even before we knew it.
But incredibly, the inner pane remained watertight. Walsh and Piccard decided to continue the descent. After a tense, claustrophobic 4 hours and 48 minutes, they approached the bottom of the trench, only to be startled by movement on the sea floor.
Just before we landed, we saw a flatfish about a foot long, and that's a bottom-dwelling fish, so if you see one, there are others.
Nobody expected to see life at these crushing depths, but it meant the explorers had reached their goal. The very bottom of of the Marianas Trench. The depth gauge, with a reading of 35,800 feet, nearly 7 miles below the surface, confirmed the sonar findings. Squeezed inside their bubble of breathable air, the two explorers were closer to the Earth's center than man had ever been.
We took a self-portrait. That's the picture that you see. Said we're going to do it, and we did it.
But there was work to be done. Walsh and Piccard wanted to make detailed observations of the enormous trench. Unfortunately, the Trieste stirred up a cloud of fine, powdery sediment from the sea floor that obscured their view.
It's like being in a bowl of milk at that point. So, realizing we weren't going to see anything, we decided to go on back up to the surface.
Off the island of Guam, the Trieste surfaces after a descent into the Marianas Trench.
After 9 grueling hours underwater, Walsh and Piccard returned to the surface on January 23, 1960, and officially entered the record books for the deepest dive of all time. To this day, their extraordinary feat has never been repeated. The mission was a success, but the mystery remained. Geologists still didn't understand what could have formed the immense trench. And if they couldn't find the answer inside the trench, they would have to look elsewhere. Perhaps there was something somewhere on the ocean floor that might explain the trench's origins. Throughout the 50s and 60s, a team of geologists led by Princeton's Harry Hess compiled sonar data from all of the world's oceans. It was as though they had pulled out a giant plug to drain away all the water and expose the ocean floor. Their maps revealed that the Marianas Trench is just a tiny fraction of a network of enormous underwater canyons stretching right around the planet. But that wasn't all. Running parallel to the trench, on the other side of the Pacific, the map showed a giant underwater mountain range, the East Pacific Ridge. And this, too, is part of a global network, a 40,000-mile-long chain of mountain ranges that ring the globe like the seams of a baseball, to make the largest geological feature on Earth. It was a major development in the investigation, one that scientists hoped might explain the trench's formation. The next step was clear. Investigators needed to understand whether there was a connection between the trench and the East Pacific Ridge. The breakthrough came from the unlikeliest of sources. During the Cold War, the U.S. built a vast network of underground seismometers to pick up atomic bomb testing around the world. Inadvertently, the seismometers also detected naturally occurring earthquakes. When geologists plotted these on a map, a pattern emerged. The earthquakes were clustered along the ocean's ridges and trenches. It was a discovery that transformed our understanding of the Earth. Geologists realized the friction that causes earthquakes comes from movements that must be occurring deep beneath the ridges and trenches.
With this great investment in seismology, it became possible to locate very precisely where earthquakes had occurred. And it was these things, the precise location, the depth, and the motion, that really gave the outlines of plate tectonics.
It was the birth of an extraordinary new theory. The solid layer of rock, the crust on which the land and ocean sits, is broken up into a series of vast slabs that geologists call tectonic plates. It's these plates that are moving, grinding past each other, and triggering earthquakes. The underwater ridges and trenches sit on the boundaries between tectonic plates. The East Pacific Ridge and the Marianas Trench lie on opposite edges of the Pacific Plate. The journey to discover what formed the Marianas Trench is accumulating additional evidence. The Trieste dived to the bottom of the trench and confirmed that it is the deepest point on the planet. Sonar maps then revealed the East Pacific Ocean ridge running parallel to the trench. To solve the mystery of the Marianas Trench, investigators needed to find out exactly what was happening at the East Pacific Ridge, and that meant exploring these vast mountains, 8,000 feet underwater. The pieces of the Marianas Trench puzzle are falling into place with the knowledge that it lies on the western edge of the Pacific tectonic plate. On the opposite side of the plate lies the East Pacific Ocean Ridge, part of an enormous chain of underwater mountain ranges that ring the globe to create the largest geological feature on Earth. Scientists had a hunch that this colossal ridge might help explain how the trench was formed. And they found a major clue halfway round the globe, where the ridge passed beneath the middle of the Atlantic Ocean. During the Cold War, the U.S. Navy developed a new technique to spot Soviet submarines. They scanned the seas with a tool called MAD, a magnetic anomaly detector, which could pinpoint steel hulls lurking in the deep. But they stumbled across something else. Running parallel on either side of the ridge, they found strange stripes of magnetic rocks, alternating positive and negative away from the ridge's peak.
Here's the mid-Atlantic ridge coming down through here. Almost perfectly symmetric on either side of that are these white and black stripes. These have often been called zebra stripes.
Geologists know that the Earth is like a giant magnet with a north and a south pole. But the magnetic poles aren't fixed. Every 300,000 years or so, the magnetic field suddenly flips 180 degrees. When the field flips, a compass that was previously pointing north will swing to the south.
This reversing of the Earth's magnetic field is a very interesting and exciting but very puzzling phenomenon for geophysicists to explain.
Scientists think this reversal explains the stripes either side of the ocean ridge. In the 1960s, geologists discovered that molten volcanic rock, known as magma, swelled up from deep underground to create the ridges in the Atlantic and Pacific. As magma wells up between the tectonic plates, it pushes the seafloor up and forms the colossal mid-ocean ridge thousands of feet high. When the rock is hot and molten, its magnetic minerals line up with the north-south direction of the Earth's magnetic field. As the magma cools, the minerals are locked in position. These rocks act as a permanent record of the magnetic pole's location when the rocks were formed. As more and more magma is forced up, the old crust is pushed away from the ridge and records the reversals in the Earth's magnetic polarity.
If you have reversals of magnetic polarity, then the seafloor acts sort of like a tape recorder and records these changes in magnetization. Then the pattern of magnetic stripes allows people to calculate the speed at which the plates are moving apart.
The zebra stripes are proof that over time, the seafloor in both the Atlantic and the Pacific is spreading away from the ridges at a rate of more than 2 inches a year. But geologists needed proof that magma created the ridge. If red-hot molten rock is forming the enormous mountain range in the Pacific, the surrounding water should be warm. In 1977, a team of scientists set out to discover whether this warm water really existed. Dudley Foster was the pilot for these historic dives.
It's been an exciting occupation because you're on the cutting edge of science. New discoveries all the time. Every cruise, there's a new group of scientists with new scientific objectives, and there's the exploration and the discovery. And that's really what puts the thrill in the job.
For weeks, the crew scanned the undersea mountains without success. And then they hit the jackpot. A bizarre pillar of rock, spewing hot, toxic gas.
And we saw the water was sort of shimmering, sort of like bubbling in a glass teapot or something. We stuck the temperature probe in there and measured 38, 39 degrees Fahrenheit, which was really amazing because the ocean's a huge heat sink. So to see something warm like that was kind of startling.
In these pillars of rock, the expedition had found the heat from the magma surging up from deep inside the Earth. It wasn't warming the water evenly along the ridge. It was channeled up through strange hydrothermal vents.
When you make these discoveries, you don't know how significant they are. The true significance of them maybe takes several years to appreciate. And this was one of those times.
For the investigation into the Marianas Trench, these vents are a decisive piece of evidence. They confirm that magma is continually creating new crust at the Pacific Ocean ridge. And magnetic zebra stripes prove that old crust is pushed away from the ridge towards the other side of the Pacific Plate, towards the Marianas Trench. But this presents scientists with a puzzle. If new crust is being created at the ocean ridge and the Earth isn't expanding, then the old crust must be disappearing somewhere else.
The reason that there's not getting bigger with seafloor spreading is because the same amount of seafloor is being destroyed in the Pacific.
Something in the Pacific Ocean is devouring the seafloor, and all the evidence points to the Marianas Trench. In the hunt to discover what formed the Marianas Trench, scientists now know crust created at the ocean ridge is being devoured somewhere and by something in the Pacific Ocean. They suspect the Marianas Trench is involved. But the proof would come not from the trench, but from these. The Mariana Islands, a chain of volcanoes that break through the ocean's surface 200 miles west of the trench. Scientists noticed the island chain mirrors the trench's exact shape. This led them to think the trench was responsible for the island's creation.
If you see pictures of the Marianas Trench, it's curved, and the line of volcanoes that it generates is curved exactly parallel to it.
Geologists believe that the trench formed the volcanoes via a process called subduction. Subduction occurs where two tectonic plates collide. As they grind past each other, the heavier plate is pushed beneath the lighter plate. The descending plate is forced down into the Earth's intensely hot interior called the mantle. It takes with it water and sediment built up over millions of years.
Volcanoes form above subduction zones not because the Earth is hotter there, but because this is where we're taking the water that once was in the ocean. It's taken into the mantle and gets sweated out, causes the mantle to melt, and this magma is what then rises and erupts explosively out these volcanoes.
The water in the sediment forces magma to swirl up and push through the plate above. And when it breaks the surface, it creates volcanoes, like the volcanoes that form the Mariana Islands. It was subduction that formed the islands west of the trench and gave investigators the breakthrough they'd been looking for. Because here, at last, was a process powerful enough to create the Marianas Trench. As the descending plate dives down, it digs into the mantle. Here, the colliding plates form a trench, a giant crease in the ocean floor. It seemed that scientists had finally explained how the trench was formed. There was just one problem. A very large problem. Around the world, subduction zones cause violent earthquakes and catastrophic tsunamis.
We know subduction is happening because of the active earthquakes, and these are the most devastating earthquakes. This is the earthquake that generated the tsunami in Sumatra. Also, the other very large earthquakes in Alaska and Chile.
But the Marianas Trench, the deepest subduction zone in the world, hasn't caused a devastating earthquake since records began in the 17th century. Investigators needed to know why.
That's the $60,000 question.
They hoped the trench's shallower western edge might provide the answer. Here they found an intriguing chain of underwater hills 2 miles below the surface of the sea. Engineers drilled down into the hills and collected core samples. And when the scientists analyzed the samples, they discovered the hills were actually volcanoes. And they spewed out not lava, but mud. The fine powdery mud is made up of a soft type of rock that has been ground up in the subduction zone. It seemed this soft rock might explain why there have been no major earthquakes at the Marianas Trench.
Everybody has a sense of what a volcano is, but not all volcanoes erupt igneous rocks. There's some volcanoes that erupt mud, and a certain kind of, an unusual kind of mud in the Marianas is made out of serpentine. And serpentine is a very weak rock, and it can be scratched with a knife or something like that.
Investigators realized the grinding plates crush the soft rock to form a lubricating mud that prevents large earthquakes. Then the mud bubbles up to the ocean floor, where it forms the strange mud volcanoes found along the trench's western edge.
Other parts of the world, like the Andes or maybe Indonesia, you've got 2 plates that are grinding together, and one of the plates is quite strong. And it takes a big earthquake to rupture that plate interface. But if these rocks are weak, like they are in the Marianas, where you've got these serpentinites, those are very weak, and it doesn't take much energy at all to get the 2 plates to glide one past the other.
At last, geologists had discovered what created the Marianas Trench. 50 million years ago, the Pacific Plate slipped under the edge of the Philippine Plate. As it bent and dived into the Earth's mantle, it formed the colossal Marianas Trench. And the plate is still moving. Like a giant conveyor belt, the Earth's crust travels slowly across the Pacific Plate, from its birthplace in the East Pacific Ridge to its graveyard 10,000 miles away in the Marianas Trench. Today, the Pacific Plate's movement can be tracked in real time.
Confirmation has come from GPS technology, where we can actually put a transmitter on an island and come back year after year and actually follow it moving a few centimeters a year towards the trench.
It's devouring the crust at a rate of 3 inches a year, about as fast as a human fingernail grows. Every 4 million years, it swallows an area the size of the United States. By consuming the crust created at the Pacific Ocean ridge, the ravenous Marianas Trench is the world's largest recycling plant. But there was one remaining and major piece of the puzzle to find. Scientists still didn't know why it is the deepest trench on Earth. They suspected the age of the seafloor at the bottom of the trench may provide the answer.
It turns out there's a really strong relationship between the age of the seafloor and its depth in the water.
In 1999, a team of deep-sea drillers returned to the trench to collect core samples.
One great thing about drilling the ocean crust is we actually got pieces of it. So we're holding in our hands here the material that's actually getting subducted at the Marianas Trench, and it turned out to be 170 million years old. So we can say with confidence that's the oldest ocean floor before it's getting swallowed up in the mantle at the trench.
But why is this piece of rock the oldest on the ocean floor?
The seafloor at the Marianas Trench is so old because it's been so long since it was born. So it was born in the equivalent of the Eastern Pacific today, and it's just been going on longer than any other place in the oceans before it's been subducted.
The Pacific Plate is the planet's largest tectonic plate, covering an area 11 times the size of the United States. When crust bubbled up at the ridge 170 million years ago, it was light and buoyant. But as it traveled 10,000 miles across the plate, it cooled and became compact and dense. Over millions of years, the dense crust got heavier and began to sink into the mantle below. Scientists realized that because the crust at the Marianas Trench is the oldest ocean crust, it's also the heaviest and so has sunk deeper into the mantle than any other area of ocean crust. Here at last was the explanation for the trench's extraordinary depth. The picture of the Marianas Trench is almost complete. Volcanic islands mirroring the trench's exact shape lead scientists to believe it runs along a subduction zone. And slippery mud volcanoes explain why it doesn't create large earthquakes. But one question remains unanswered. Towards the trench's southern end, the vast chasm drops a further 2 miles to its lowest point, the Challenger Deep, 7 miles beneath the waves. The question is, what makes it plunge so deep? The investigation into the Marianas Trench has one final puzzle to solve. At the trench's southern end, the sea floor plummets a further 10,000 feet into a 7-mile deep chasm called the Challenger Deep. It's the lowest point on the planet. But so far, scientists have been unable to explain why this one section of the trench is so deep. Now, they believe the shape of the descending tectonic plate may hold the answer.
The Challenger Deep, in addition, is a little bit deeper because of some peculiarities relating to how the slab that's going down is behaving.
A narrow slab of crust has torn away from the Pacific Plate's descending edge.
Well, it's basically got to do with how the slab pushes the mantle out of the way. Where you have a narrow slab, like you have at the Challenger Deep, it can sink almost vertically because the mantle that it's trying to displace can move around out of the way.
Investigators have finally unraveled the mysteries of the Marianas Trench. And in the process, they've made a discovery with implications that stretch far beyond the trench itself. Studying the ocean ridges led geologists to believe that magma welling up at the ridges was pushing the plates apart.
How much weight does that
But the exploration of the Marianas Trench has changed this idea forever.
People used to think that maybe the magma would kind of push the plates apart. And that idea is largely discounted now.
As the ocean crust travels from the Pacific Ocean ridge to the trench, it changes from a buoyant, red-hot magma into a colder, denser, and heavier crust. The plate's leading edge becomes so heavy that it drags the rest of the plate along behind it.
The heavy, cold plates at the trenches are sinking down into the mantle and pulling the plates apart at the ridges, and the magma just passively fills in the gaps.
The investigation into the Marianas Trench has revolutionized our understanding of how the Earth's plates move. We now know a worldwide network of subduction zones drag tectonic plates around the globe, powering the movement of continents over millions of years, and moving the very Earth we stand on.
The plates that are moving fastest on the Earth are the ones that have all the trenches.
The Pacific Plate is the fastest moving of the 9 major plates on the planet because it is surrounded by dozens of destructive trenches like the Marianas. They are consuming the ocean crust faster than the ocean ridge can produce it. Over millions of years, the Pacific Plate will shrink until sometime in the distant future, the largest ocean on Earth will disappear. Australia will crash into the United States, reshaping our planet. Perhaps one day, downtown Seattle will compete for real estate with a suburb of Sydney, Australia. And all because of subduction zones like the Marianas Trench. But for all its significance, man has only ever dived to the bottom of the trench once, and there are no immediate plans to return.
Imagine asking someone, what is the flora and fauna of California? And saying that someone spent 10 minutes there, picked up 2 ants, come back, and said they've sampled California. That's probably how well we know the Marianas Trench.
To date, less than 5% of the world's oceans have been explored. But only by returning to the ocean's very deepest reaches will we fully comprehend the incredible forces that recycle and rebuild our world.
The way I like to think of it is that ocean exploration leads to new research questions. And if we don't have exploration, we don't even know the right questions to ask.
It is now known what a geological wonder the Marianas Trench is. Since this deep chasm in the Earth's crust was first discovered with a length of rope and a lump of lead more than a century ago, evidence has piled up. A record-breaking dive to the lowest point on Earth. Giant undersea mountain ranges with bizarre magnetic zebra stripes. Proof that the ocean crust is spreading towards the hungry Marianas Trench, lined with slippery mud volcanoes which prevent devastating earthquakes. And the planet's oldest ocean crust, the reason that the Marianas Trench is the deepest point in the oceans. In the darkest and most remote place in the world, scientists have added to their knowledge about the powerful forces that contribute to the dynamic story of our planet.